Mhm. We continue our lesson. For step number 7, we find the sizes of a cross-section of the frame in the form of a circle. Material of a frame is steel 20X brand. Using conditional durability as the direct flat bending, we find the necessary resistance moment of the cross-section as for beam, according to this formula. Sigma in the square brackets is the allowable stress. For ductile materials, sigma with the square brackets is equal to sigma y divided by ny, where sigma y is the yield strength of material. Ny is the factor of safety on a yield strength. Ny is equal to 1.5 by default. For the steel 20X brand, table 2, 20X, sigma y for hundreds megapascals. This is 400 megapascals. And we got the result 267 megapascals. And the Wx is the necessary resistance moment, bigger and equal than Mmax, maximum, divided by allowable stress. Mmax from the diagram of bending moment, 117. This is the maximum value. Divided by 170 multiplied by 10 in power 3 kilonewtons by meters in newtons by meters multiplied by meters, divided by 267 multiplied by 10 in power 6 megapascals in pascals. And we receive the 636.7 centimeters in power 3. The step number 8. We find the sizes of a cross-section of the frame in the form of a circle, as for beam. This, according to this formula, P multiplied by D in the power 3 divided by 32. I hope you remember this formula. Bigger and equal than 636.7 centimeters in power 3. And we find the D, diameter D, 18.65 centimeters and 186.5 millimeters. This value D must end with 0 or 5 millimeters. And since the D is equal to 119, this value end with 0, bigger than this value, and with 0 millimeters and 19 centimeters. And we find the WX circle with this the diameter 19. We got this value. And the area of the circle, according to this formula for circle. And we got this result. For beam, this is a finish. And for frame, after finding the sizes of the cross section for the frame, it is necessary to make a check, taking into account the action of the normal force, using the most complete strength condition. According to this formula, sigma maximum is equal to M maximum divided by WX circle plus N divided by A area circle. The normal force N is taking for the same section where the maximum bending movement Mmax acts. This value 170 acts on the first segment, and we find the N for first segment. This is 40 kilonewtons. And we write this formula: 117 multiplied by 10 in power 3 divided by this value 673 multiplied by 10 in power minus 6 meters in power 3 in centimeters in power 3. We do in meters in power 3, plus 40 multiplied by 10 in power 3 kilonewtons in newtons, and this area of circle 283.4 multiplied by 10 in power minus 40 centimeters in power 2 in meters in power 2. This value in meters in power 2. And we got this result, 254 megapascals. This value less than allowable stress. Allowable stress is equal to 267 megapascals. Our maximum, sigma maximum, less than allowable stress. That's all. This is your future design work. Do you have any questions? Thanks, guys, for attention. See you later.